Dr. Taylor. I work in the Division of Forensic Medicine and Toxicology, and I'm going to be talking about properties of alcohol, its absorption and distribution. When we talk about alcohol, we're referring to ethyl alcohol, which is C2H4OH, a hydroxyl, and that's also known as ethyl alcohol or ethanol. This is a colorless, odorless fluid which is fully soluble in water and has a boiling point of 78 degrees Celsius. It also has a specific gravity of 0.78, meaning that relative to water, it is less dense and lighter. So if you have 1 ml of water, it would weigh 1 gram, but if you have 1 ml of alcohol, it will only weigh about 0.8 grams. Alcohol is sold in a volume for volume percentage, meaning that if you have 100 ml of a liquor, which is about 10% alcohol, such as wine, that means that 10 ml of that will be pure alcohol, but because of the differences in specific gravity, that is 8 grams, and that is known as 1 unit. But different alcohols come in different strengths, and therefore different volumes make up 1 unit. For example, beer, which is about 5%, requires 200 ml to make up 1 unit. Or a strong spirit, like brandy, which is about 45%, is only 25 ml to make 1 unit. And the strength of liquor is regulated by the Liquor Products Act, number 60 of 1989. Alcohol is absorbed according to Fick's law by simple diffusion, meaning that absorption is proportional to the concentration gradient as well as proportional to a constant. Once in the body, only 20% is absorbed in the stomach, whilst 80% is absorbed in the small intestine. This is because the small intestine has a greater capillary surface area, a greater mucosal surface area, and a thinner mucosa. Otherwise, small amounts of alcohol can be absorbed by inhalation. It is not absorbed through the skin. It can be absorbed intravenously, and it can also be given subcutaneously, although it is irritative and causes vasospasm. Various factors affect the rate of alcohol absorption. For example, if the patient is post-gastrectomy or has an empty stomach, the alcohol passes immediately to the small bowel where it's rapidly absorbed. Similarly, factors that increase mucosal blood flow also increase the rate of alcohol absorption. So, for example, gastritis, other inflammation, or warm food. On the other hand, food in the stomach decreases absorption. This is because it physically blocks the mucosal barrier. It absorbs some of the alcohol. It also slows gastric emptying. And food also increases hepatic metabolism. Another factor that affects the rate of alcohol absorption is the strength of the alcohol that you take in. If you ingest a very strong alcohol, it's actually absorbed slower because it causes pyloric spasm and increases the mucosa, causing mucus to be released, which blocks the surface area. In contrary to this, alcohol, which is 10 to 20% strength, like wine, is maximally absorbed. Then, drinks which are carbonated are traditionally said to increase alcohol absorption because they cause vasodilation and also relax the pyloric sphincter. But in experiments, they have a variable effect on absorption in individuals. Drugs can have a variable effect on alcohol absorption, mainly relating to their ability to increase or decrease gastric emptying. Drugs that decrease alcohol absorption include adrenaline, both opiates and beta blockers, methamphetamines, loperamide, smoking, and coffee. Drugs that increase gastric emptying include Maxolon and the antibiotic erythromycin. Other factors include head injury, which normally decreases gastric emptying, and anxiety, which can increase or decrease gastric emptying. Once it's been absorbed, alcohol is distributed into the total body water. And at equilibrium, the concentration in the venous blood equals the concentration in the arterial blood. It's distributed according to an R factor, which varies according to a particular tissue's water concentration. And if you're considering the whole body, the R factor is equal to the concentration of alcohol in the body as a whole divided by the concentration of alcohol in the blood. Since blood is essentially water, this is always going to be a fraction because the body as a whole also includes bone and fat, which don't have much water. Now, the R factor of the brain is 0.73, which is very close to 1, meaning that we can use the blood alcohol concentration to correlate with what must be present in the brain tissue and thus affecting the neurological status of the person. So if we consider a fat person and a thin person of the same weight, the fat person has a large amount of fat and relatively little water compared to the thin person whose muscles contain a lot of water. This means that the R factor of the fat person may be 0.5, while the R factor or distribution factor of the thin person will be higher. And practically what this means is that if they both consume the same amount of alcohol, all the alcohol is concentrated in the relatively small amount of water in the fat person compared to in the thin person where it's distributed over more water. So the blood alcohol concentration of the fat person is higher than the blood alcohol concentration of the thin person. Okay. The Widmark formula can be used to calculate the amount of alcohol consumed. The Widmark formula is A equals P times C times R. A is the amount of alcohol consumed in grams. P is the mass of the person in kilograms. C is the blood alcohol concentration in grams per kilogram. And note that the laboratory reports this in grams per deciliter, a deciliter being a tenth of a liter, so that value must be multiplied by 10 to get grams per kilogram, and R, the distribution factor that we've just dealt with. So because we cannot actually measure the R value for different individuals, what we do is we use an R value of 1/2 for a fat person, 2/3 for an average person, and 3/4 for a lean person. Then because women are usually fatter than men, we can use an R value of 0.7 for men or an R value of 0.6 for women. The Widmark formula can also be used then to back calculate the amount of alcohol that the person must have consumed if we consider that 1 unit is 8 grams of alcohol. But that doesn't consider the amount of alcohol that's already been eliminated or that's been drunk but not yet absorbed from the stomach or GIT.